up in our next lesson in science, atomic nuclei. Our goals for this lesson are to determine the number of protons, electrons, and neutrons for an element given its atomic weight and number, define isotope, describe the characteristics of alpha and beta particles and gamma rays, distinguish between subatomic particles, and recognize that nuclear structure is not fully understood. Look at your vocabulary words. The total number of protons plus neutrons in an atomic nucleus is the atomic weight. An atom with a standard atomic number and chemical properties but different atomic weight and physical properties is isotope. A particle 1/8 the mass of protons, charge varies, is a meson. A neutral particle of nearly zero mass produced by decaying nuclei are neutrino. Nuclear particle of the mass of an electron but with a positive charge is a positron. Atomic nuclei. We have studied models of the structure of the atom. The atomic structure that is commonly understood today is based on the model proposed by Danish physicist Niels Bohr. Okay, so go ahead and let's write our date. And today we're going to talk about atomic nuclei. Niels Bohr. Bohr's model suggests that electrons move around a nucleus in specific paths. Okay, so Niels Bohr was a Danish physicist. He suggested that electrons move around a nucleus in specific paths. Okay. He said that electrons move around the nucleus in specific paths. The atom is mostly open space. Why is that moving? And the nucleus is located in the center of the atom. I don't know why that's moving. That the nucleus contains most of the mass of the atom, and that the mass is made up of protons and neutrons. Okay, the nucleus contains most of the mass of the atom, and that the mass is made up of protons and neutrons. Do scientists know what the structure of the nucleus is? How can protons stick together when we know like charges repel? What is the design of the Creator with regard to the nucleus of the atom? Let's see if we can find some answers. Okay, so today we're going to talk about atomic nuclei. Niels Bohr was a Danish physicist. He stated that electrons move around the nucleus in paths. The atom is open space. The nucleus is in the center of the atom. The nucleus contains most of the mass of the atom, and the mass is made up of protons and neutrons. And his model of the atom is what we use today. Okay, so his model of the atom is what we use today. Okay, nuclear composition. We have already found that the nucleus contains at least the particles of protons and neutrons. Scientists have carried out thousands of experiments and discovered over 80 particles making up different nuclei. Electrons, neutrons, protons are made up of even smaller constituents, but we will confine our study to 7 particles and 1 ray. Okay. So nuclear composition. Okay, so we're not going to talk about everything, but we're going to talk about 7 particles and 1 ray. So we're going to start with protons, because we know that there are protons in the nucleus. Protons are positively charged particles and are given the mass number of 1.007582. All atoms have at least 1 proton, and each element is known by the number of protons in its nucleus. Okay. We said before that they're positively charged. I'm going to put a plus for positive charged. Okay, they're given a mass of 1.007582. All atoms have at least 1 proton, and each element is known by the number of protons in its nucleus. So we talked about this before. Elements are known by the number of protons. The number of protons. It says in its nucleus. Well, the only place that protons are in the nucleus. All atoms of the same element have the same number of protons. The number of protons contained in an atom is its atomic number, and we said that. I'm going to put atomic number here again. So if I find out how many protons an element has, that's its atomic number. Okay. Now let's talk about, what does this say? Let's talk about neutrons. We said we're going to talk about Okay, we said Bohr's model of the atom is what we use today. Now we're going to talk about nuclear composition. Protons are positively charged. They have a mass of 1.007582. Elements are known by the number of protons, which is called the atomic number. Now we're going to talk about neutrons. Neutrons are particles with no electrical charge. Okay, so they have no charge, and their mass, they have a mass of 1.00897. Slightly greater than that of a proton. Because this is 1.008, that's 1.007. So it looks like about a thousandth. So it's slightly greater than a proton. Together with protons, they make up the atomic weight of atoms. We know that the nuclei of the same amount have the same number of protons, but the atoms of an element can have differing numbers of neutrons.